Dear students, Mr. Kitchens here again, and today we're going to do an equidistant proof. So as you can see right now, we have the diagram here where we have two lines. These are supposed to be straight lines crossing each other. And the given information is that segment or line, if I would have continued, it would have been a line, I guess. It's two segments, I should be more correct on that. LM is a perpendicular bisector of JK. So there's some key information in there that when you come across this kind of problem, you have to pull that out. Now, one other reminder, when you do these assessments in Brain Honey, you're going to come across problems that they've shown where somebody else has worked it. And they're going to ask you questions like, where did the proof go wrong? Or where's the mistake? Or fill in the blank. And you're going to want to just take a look at the proof right away and see what they did and try to follow it. And unfortunately, the mind and the eyes are not quite as critical when you do it that way. So what you need to do is you just need to work the proofs from scratch on a separate sheet of paper and just walk through those and try to make sense of the proof from start to finish. If you can do that independently on your own sheet of paper, then when you get to that question in the quiz, it's going to be so much easier because you're going to have a much more critical eye and you're going to easily see what went wrong. If you're having trouble with the proof and doing it yourself, then that's when you need to come to me and contact me and we'll get together and we'll talk about it. It's one of the reasons why I'm putting these proof videos together, so you can get a little bit more insight into how to approach these. So this problem here came out of one of your questions in the quiz, and it basically, I think, was one where you had to show which proof was incorrect. And instead of just doing it that way, I want to walk you through this proof. So let's go back to the key information here. LM is perpendicular to JK. So right away we want to be thinking about what angles we have right here. So we have a couple right angles, 90 degrees, because that's the definition of perpendicular. So we know that's going to help us. We also know, and well, let me underline that, we also know that it's a bisector. And if you know about that front end saying bi means two. And that means that LM cuts JK into two pieces that are equal. It cuts this whole piece in half. And when you do that, the halves are equal to each other. So now we know that this segment and that segment are congruent. These are the kind of things you got to pull out of the words that they give you up front, because there's a lot of clues in there. So what are we trying to prove here? We're trying to prove that point L here is equidistant from J and K. Well, equa is kind of the prefix used, a root word used for equal. And what it's meaning is that the distance from L to K is the same as the distance from J to K. So if you were taking a trip from L to J, you probably wouldn't kind of mosey around up here and come around here and go like over here and over to here, would you? No, you'd go as the crow flies and you do a straight shot to J. And going from L to K, you do a straight shot to K. And lo and behold, when you make those constructions, which you want to put that in here when you do your proof, you could say something like form segments LK and LJ, yeah. And by construction. And you want to put that in there. One of the things you're going to notice with a lot of these proofs, not all of them, but a lot of them, is you're going to be forming triangles. These are key friends. If you can get to where you're understanding the ways to show congruent triangles, then you are going to have so much more success with all these proofs. And on that note, if you recall, we've given you different postulates that help you prove these triangles. And here's just a few of them, or actually here's all four that we have. And as you notice, there's three pieces to each one of these postulates. So you got four postulates. On this one, you have a side, side, and side. So that's three sides of one triangle are congruent to three sides of another. If you can show that, then you can show the two triangles are congruent. Now, as you can see, there are more than three pieces on a triangle. There's actually a 1, 2, 3 sides and 1, 2, 3 angles. So there's 6 pieces. All you got to do is be able to show 3, and you can get that congruency. So keep that in the back of your head as we keep going through this. So we got the segments. By construction, we formed the 2 triangles. We've actually shown, because we picked out the information on perpendicular, that we have 2 angles here. And they're congruent. So now we can put a mark on that. I'm going to put that mark right there and right there. So, and I'll put double dashes so it kind of stands out a little bit different. And we already knew these were equal because it was bisected. So JK is twice as big as JN and KN. So they must equal each other. So those pieces match. That's 2 pieces. And now we just need a 3rd piece. And some of you may be able to visualize this differently if I redraw this image, because they're kind of stuck together. So if I were to draw this, and it's going to be a little bit smaller down here, we kind of have 2 triangles like this, right? And then another one right there, kind of like that. And we've got an L here and an L there and an N there and an N there and a J and a K. So that's kind of what we have going on there. So now when we see it that way, we notice we have an LN on both of them. And guess what? That means that's the same segment. And we can definitely say the same segment is congruent to itself. So let's get some of these reasons in here, because now we got 3 pieces. And we've got a side here, an angle, and a side. So it looks like we're going to be using side, angle, side to show these 2 triangles are congruent. Now what we're trying to get to, and I should have marked this at the front, is we're trying to get to our goal, which is to show that this segment and that segment are congruent. Those yellow highlighted markers are our goal. That's what we're trying to do. And it says it down here. We could also just say we're trying to prove that LJ is congruent to LK. That's the finish line. So we form the segments by construction. We also can say that JN is congruent to KN, and that's definition of bisector. And you don't have to put perpendicular because it's just really a bisector. It could have been at an angle. We could have had a line that cut through like this, right through that middle, and it still bisects that, so that would still be a bisector. But because it's perpendicular, the angles were 90, and that was handy. So let's erase that line. That's pretty... Okay. That's our first piece. Those pieces there. And the angles, so we can say that angle JNL, you notice I went from here to here to here. The name for this, you got to have the vertex letter in the middle, so that's the name of that angle. And that's congruent to, and we want to keep the same corresponding parts, so we started with J, we want to start with KNL, is the name of that one, KNL. And that's, you could say, is definition of perpendicular or bisector. Perpendicular or perpendicular. That's the second piece. So now we have 1 piece, 2 piece. We need that 3rd piece. And we got that by segment LN is congruent to segment LN. And that's the good old reflexive property. Now we have 3 pieces. We can now say our triangles, J and L. Notice it's a full triangle now, not just the angle. It's congruent to K and L. And I forgot my triangle in there. And that's by SAS. Side, angle, side. And they're adjacent to each other, so that works for me. So finally, how do we get to LK and LJ? That's the beauty of this next thing that we call CPC-TC. It's CPC-TC. And that stands for corresponding parts of congruent triangles are congruent. It's kind of like a free get-out-of-jail card. Corresponding parts. Basically, if you prove 3 other parts are congruent on 2 triangles, and we had this part, we had that part, and we had this part equal to these, congruent to these. So once we did that, we can say the other three parts are congruent. And this was just a leading up to this next step, which is LJ is congruent to LK. And that's where we wanted to finish. And that's because of CPCPC.